All right, welcome back. So we're going to do another example. This is number 14. Okay. 2z double prime plus z equals 9e to the 2t. Okay, so let's start. We're going to find the homogeneous solution first. So homogeneous part. I just said it two different ways in one sentence, which is awesome, right? So 2z double prime plus z equals 0. Okay, so that gives us 2r squared plus 1 equals 0. Okay, remember we're assuming z equals e to the rt when we do that, right? So let's see, r squared equals -1/2. R equals plus or minus I divided by 2. So our homogeneous solution, y0 of t equals c1 cosine t over 2 plus c2 sine t over 2. Okay? Now we have to look for our particular solution. Okay? Now, this one's particularly simple. I did not mean that pun, but it came out and I love it. And we're going to take our yp is going to be basically a multiple of the forcing function. Okay, that's what we call this. This is the forcing function. Okay, so our yp of t let me change that. Okay, so our particular solution is going to be yp of t, and I'm going to make it sum a e to the 2t. All right. Okay, so yp prime, which we don't really need, but we need it in order to find yp double prime. So yp double prime is 4a e to the 2t. So now we're going to take and we're going to plug this in to our total solution and see if we can get something. Okay, so let me bring that down, and actually I should be using z as my independent or my dependent variable. So let's do that. Let's change that to z0 z sub p. Okay, so where was I? Oh, yes. So 2 zp double prime plus zp should equal 9 e to the 2t. Okay, so that means we're going to get 2 zp double prime was 4a e to the 2t plus zp is a e to the 2t should equal 9 e to the 2t. So, sorry, this one, like I said, it was particularly easy. 9a to the 2t, 9a e to the 2t should equal 9e to the 2t. So a equals 1. So z of t is going to be, we have our homogeneous part, z1 cosine t over 2 plus c2 sine t over 2 plus our a is 1 e to the 2t. Okay. All right, I think we can do another one on this page. We just make it a little smaller. Okay, so let's take this one's number 16, and it says theta double prime minus theta of t equals t sine of t. Okay, so let's start by taking, again, the homogeneous part. Okay, so the homogeneous part is theta double prime of t minus theta of t equals 0. Again, we're going to assume theta of t equals e to the RT. Put that into our machine to solve this. R squared minus 1 equals 0. Okay. So R equals plus or minus 1. Okay, so our homogeneous solution, our theta of t is going to equal theta 0 of t, C1 e to the t plus C2 e to the negative t. Okay, and we have a particular solution. Now, our particular solution needs to match this t sine of t. Okay, so we're actually going to have this one's particularly, it's difficult. Okay, it's not really particularly difficult. It's just, I like bad puns. Sorry, you're going to have a lot of videos with them. Okay, so particular solution. Okay, so our particular solution, theta p of t equals, now we need to account for the t, okay? And we also need to account for, in this case, I don't think we do, but yeah, we do. We need to account for the fact that we have sines and cosines, really, okay? So our particular solution is going to be A cosine t plus B sine t plus CT cosine t plus DT sine of t. Okay, so it's this t sine of t makes it just a pain. If that t wasn't there, it'd be a lot easier. Okay, but that t is there. So let's go ahead. We got to take this first and second derivatives. How much space do I have? I got to make this a little smaller. Okay, so theta p double prime. I'm sorry, theta p prime first. Theta p prime of t is theta p prime is negative a sine of t plus b cosine t plus, let's see, c cosine t minus ct sine of t plus d sine of t plus dt cosine t. Okay, right? Okay, let's see if there's anything I can put together. Yeah, I can put these two together and I can put these two together, right? So let me write that before I take the next derivative as d minus a sine of t plus b plus c cosine t minus ct sine of t plus dt cosine t. Okay, so that's still theta p prime. Okay, now let's take theta p double prime. Theta p double prime is, let's see, d minus a cosine t minus b plus c sine of t minus minus c cosine t, or sorry, sine of t minus ct cosine t plus d cosine t minus dt sine of t. Oof. Okay. Let's go ahead and see if I can put any of those together. Or rather, let's put what I can put together. So I have cosine t here. So d minus a and a d here. So it's going to be 2d minus a. In the sine of t, I've got negative b plus c minus c. So that's going to be minus, that's going to be, let's put it as plus, hate when I do it this way, minus, b plus 2c sine of t. I'm just going to check that I have the signs right. So there's a minus b, minus c, minus 2c. Perfect. Okay. Now the t's. So we've got minus ct cosine t minus dt sine of t. Okay. So there's our theta p double prime. Okay. Now we're going to take and we're going to plug those in to our original equation. Okay. So theta p double prime minus theta p should equal t sine of t. And this is where I'm absolutely thrilled that I have this, because I can go copy, that's theta p double prime. Minus, let's put a big old parentheses around that, theta p, which was up here, has to equal t sine of t. Okay, let's make that all blue. Okay, so let's go ahead. We have to match up all the cosine signs and t sines, t cosines. So cosines. Where's all the cosines? I have 2d minus a, and I have another a here, right? So I have 2d minus 2a equals 0. So that means d and a are going to be equal, right? Okay, let's do the c, or the signs. Okay, so I have negative b minus 2c minus b is going to equal 0. So, let's see, minus 2b minus 2c equals 0. So b is going to equal c. Okay, let's do now t cosine of t. T cosine of t, let's see, I have minus ct minus 2ct. That's going to be equaling 0, right? I'm sorry, yeah. So minus ct again. So c equals 0. So now that c equals 0, we know b is going to equal 0 as well. Now let's look at t sine of t. T sine of t, we're going to have on this side, we have negative dt, negative 2 dt equals t. So we're going to have negative 2d equals 1. Oops. Okay, so d equals negative 1/2. Okay, that means a also equals negative 1/2, right? Let me just check that because I have a different thing from last time. Oh, let me just check all of this because I have a different thing in my notes. So, never mind. I'm going to do it and check it later. And if I get it wrong, if I got it wrong, I'll just remake the video. So, our theta particular is going to be a is negative 1/2, d is negative 1/2, so it's going to be negative 1/2 cosine of t minus 1/2 t sine of t. Okay, I'll see you guys in the next video.